Hi, Hal. Today I'm going to explain RC time constant. The RC time constant is nothing but the time taken for the capacitor to charge or discharge to certain percent of its maximum supply voltage. So that is called RC time constants. So we can write this equation as tau is equal to RC. So if we consider this is the supply voltage, so the capacitor, the time taken for the capacitor to charge its maximum value. This time is called RC time constant, that is nothing but tau. And also the capacitor taken time to discharge, so that is called tau. So the time taken for the capacitor to charge and also to discharge to its maximum supply voltage is called the RC time constant. So if we consider a single RC circuit, so what is the equation for the RC time constant? That is tau is equal to RC. So I am considering a simple RC circuit here. So this is the supply voltage Vs. I am considering a resistance R1 and capacitor C1. The voltage drop across the resistances VR and voltage drop across the capacitance is, I have taken it as Vc. So at the time instance, so this is the switch I am using. At time is equal to 0, I am closing this switch. So at time is equal to 0, the capacitor acts like a short circuit. Maybe you know the formula Q is equal to CV. At the time instance T is equal to T0, the charge on the capacitor plate is 0. So Q is equal to 0, then it implies as voltage drop across the VC, that is nothing but 0. So the voltage drop across this VC 0 is nothing but the capacitor is acts like short circuit. So the current flowing through this old circuit is decided by this R1. So VR is equal to I into R and VC is equal to 0. The voltage drop across this VR is equal to I into R and the voltage drop across this capacitance is 0. This is at the time instance T is equal to 0. If we go through the next thing, at time is equal to infinite time, the I will become 0. The current through the circuit will become 0. Why? Because the charge on the capacitor plate is maximum, because this capacitor is already fully charged. So Q is maximum. So capacitor is acts like an open circuit. So this Q is maximum. So there is no current flow this. So it acts like an open circuit. So at that time there is no current, means voltage drop across the resistances will become 0. So VR becomes 0 and VC is the nothing but Vs. The capacitor is fully charged up to the supply voltage. So at T is equal to infinity. So VR becomes 0 and VC is equal to Vs. So we know that at time instance T is equal to infinity, we are getting VC is equal to Vs. But we should know how much time we need to provide for the circuit to get VC is equal to Vs. To find out that, we'll do a small exercise. We already know that for any circuit we need to provide tau is equal to 5 times of RC. But we'll have some clarification. Why only 5 RC? Why not 6, 7, 8? Only why we fix to 5 RC? So for that we'll do an exercise. We already in the last video we already seen that the capacitor charging formula, that is VC is equal to Vs of 1 minus e power minus t by RC. So for the simplicity, we'll take RC value is 1. So the resistance value is 1 ohm and capacitor value is 1 farad. We'll just take just for the simplicity. Okay, so in that case we'll provide the RC constant. If you provide RC time constant as 0.7 tau, what we'll get at VC and what is the current flowing through that circuit at time instance, we'll just calculate those things. So if I put RC is equal to 1, so the formula will become Vs of 1 minus e power minus t. Okay, so I have just added those formula in the calculator. So 1 minus 1 minus e power minus x. So that is same as this one. 1 minus e power minus t. Instead of t, I have taken it as x. So after that, so here I am calculating for the 6 values. First I will take this RC constant, this t as 0.7. So I will just make it t as 0.7. What is the value we are getting? So 0.50 Vs. Okay. So for that thing, the current value is 0.5 I. Okay. So next I will calculate for x value as 1. Okay. I will take it as x value as 1. So at x value as 1 tau, we are getting 0.632 Vs. And the current value will get it as 0.3 high. If you want, you can calculate this current. I have just calculated and I am directly putting the values. So I will do for one more thing. For if I keep it as 4, what is the value? So that is 0.981 Vs. So you are getting approximately 0.18 AI. I will keep x as 5. So I will get 0.993 Vs. At the time already we current will become 0. And after that again I will put one more value, that is x is equal to t. We will get 0.9975 Vs. Here current already 0. So we can observe this. So 4 tau to 5 tau we can having 0.98 to 0.99 transition. But 5 tau to 6 tau we are having only 0.9975. We can see only third decimal bit is varying. So there is no much transition from 5 tau to 6 tau. If we calculate for 7 tau also, you will get it as 0.99998. If I keep it as 8, again 0.99999. So approximately we are taking this value. This is approximately equal to 1, right? Equal to Vs. So that is why instead of taking more value, we are fixed to this 5 tau to get the maximum value. So I am showing this thing in the waveform. Just observe here. This is the time constant I am taking here. So this is the Vs value. At 1 tau, we are getting 0.3. At the 2 tau, some value will get. At the 4 tau, we are getting 0.98 Vs. At the 5 tau, approximately we are getting it as Vs. Only very small variation is there from Vs to 0.93. So very little difference is there. So we can say it as approximately Vs. So at least we need 5 times of RC time constant to capacitor charge to its maximum supply voltage. So that is why in every RC circuits that the time constant should be greater than 5 tau c. Then only we can observe the fully charging and discharging effect of capacitor. So this is the voltage versus time constant graph. From this graph what we understood is for the supply voltage the pulse width should be greater than or equal to 5 times of the RC time constant. Then only we can observe the complete charging and discharging operations of capacitors. So this is the final thing. Tau should be greater than or equal to 5 RC. So let's see one more point. One more thing, that is current versus time constant graph. So this is the current versus time constant graph. Here as we discussed before, at the time is equal to 0, the voltage drop across the VC is equal to 0 and the current is maximum. So we can see here is at time is equal to 0, the current is maximum and it is calculated by using Vs by R. So after the t is equal to infinite time, so we understood that where we can get Vc is equal to Vs at time instant 5 tau. So we are calculating at 5 tau what is the current value, that is 0. So 5 tau we are observing 0 current through the circuit. So this is the current versus time constant. Thank you.